In this video, you'll learn how to use biodegradations to predict how much pollutants that can be removed in a stormwater infrastructures. By far, most of the stormwater infrastructures has plants, microbial communities, so biodegradation is inevitable for most of the green infrastructures. In fact, because of biodegradations, any pollutants removed by filter media can be regenerated because anything that stick to the filter media, they will adjust the filter media over time. But if you have the microbial community degrade them, those filter media are renewed with time, so that it can have more surface with no pollutant, so that it can continue to absorb other pollutants. So degradation can occur in soil because of bacteria, fungi, and many other microorganisms. So here we are not, for the sake of, for the simplicity, we can assume that all of them work together to degrade it at certain rate. If you know that rate, which you can determine experimentally, you can predict how long it takes to degrade it. So let's see how we can degrade more pollutants. And as you know, degradation depends on bacteria or microorganisms. So anything that makes the microorganism survive or striving there, that will increase degradations. So that means you can add some source of nutrients, which can be compost. That's why a lot of times compost and mulch are added to the system. You can also add nutrients, but a lot of times you don't need to because stormwater has a lot of nutrients. And you can also control the oxygen because some pollutants require aerobic conditions. In fact, most of the pollutants are destroyed in aerobic conditions. Some pollutants like nitrates require anaerobic conditions to be removed. And in that case, you have to create anaerobic conditions by putting a lot of organic carbons and submerging the entire filter media. And for most cases, you for degradations, you need to have a lot of moisture because bacteria or microorganisms survive in moist environments. And which is a challenge for cases like Los Angeles or dry climate where soils become very dry. That kills a lot of microorganisms. So in that case, you have to find a way to keep it moist by using recycled water or gray water or some form of other possibility. Otherwise, degradation is not a big factor in those conditions. So how do you predict degradations? And that's very simplistic way. You can assume that degradation is a first order rate. First order rate means dc by dt. It depends on in the a rate constant k times concentration of pollutant in water. And when you solve for that, integrate it, you will get this value because dc by dc by c is minus k dt. And you integrate it c from initial c0 by c time equal to 0 to t. When you do this one, you will get this value because this one is ln c, c0 by c, this is k t 0 to t. So what that means is if you look at the pollutant removal by degradation, you can almost predict as a first order rate or exponential decay. And so this decay happens initially, a lot of biodegradation, and then it slows down over time. And that's because of a lot of different factors. So how do you improve biodegradations? Again, just have more microorganism, filter media, which is breathable, means more oxygen. Aerobic condition degrade more pollutants. So that means you can control the porosity. But in some cases, if the porosity is not if you want low porosity to deplete oxygen supply because that's required for anaerobic conditions, you can also use that factors. For example, in cases like bacteria, the nitrate denitrification, which is basically removal of nitrates, you can see that it can turn nitrate into a nitrogen gas in anaerobic conditions because when you have oxygen, basically oxygen is going to scavenge these electrons. That's why this require anaerobic conditions and it's a little bit pH. You need more protons in acidic water, then you can predict removal of nitrates. And so this is a model that used to predict removal of nitrate here. So that's something you can think of how to use it. So how the design factor? Again, the removal of nitrates depends on low oxygen conditions, High DOC. High DOC means you have a lot of organic. That organic is basically the reason why oxygen will deplete very quickly because some of the bacteria will eat that. And then DOC also supply electrons. And also you need low pH and low flow rate because this process is very slow. So that means you want to have low flow rate for things to work slowly. With that, this is just an example of biodegradations, and there are multiple ways, but this is just how you can model it. With that, let's have a quiz question so that you can look at the biodegradations. Suppose question is in which season the biodegradation rate would be expected to be lower in stormwater biofilters. So again, think of which temperature is more conducive to bacteria or something they like to live. In this case, choice is summer and winters. And summertime is high temperatures. High temperatures is normally warm temperatures is some bacteria like because they don't like to stay in the dormant conditions. So the answer is A. The second one is denitrification. Which of the design features would help increase denitrification? Choice is increase in flow rate, raise under drain outlet, cut off plants, add carbon source at the bottom. So again, there could be multiple choice. So let me pause it here so that you can have some times to think about it. So you may pause the video. All right, so let's look at what's the reason behind it. If you increase in flow rate, what will happen? That you have less contact time. If you have less contact time, bacteria will not have enough time to remove the pollutant. So increase in flow rate is going to decrease the decrease denitrifications. If you raise the under drain outlet, which is basically here, as you can see, the raised under drain outlet means you have more saturated layer. If you have more saturated layer, you have more likely to have deplete the oxygen because submerged means no oxygen cannot diffuse inside water. So this means it's going to increase removal. Denitrification increases. Cut off plants. If you cut off plants, plants are the part of denitrifications because if you take the plants out, there will be a lot less bacteria. They are not going to remove a lot of pollutants. Then they cannot take nitrates out because they can use it as a nutrient. So that means this is definitely going to decrease it. Add carbon source at the bottom. As you can see, the whole idea of carbon source is basically this DOC. The DOC is basically the source of electrons. So you wanted to have carbon. So that means this is going to increase the denitrification. So the choice is B and D. With that, you will learn all the processes relevant for stormwater infrastructure design. From next video, you are going to combine all of them together and you will couple them all together into one rate, and then you predict the removal rate in a green infrastructures.